Good evening, everyone. This is Jordan Manis, and we are here with our Module 6 interactive experiment. And today we are going to be attempting to make ferrofluid. I'm hoping that I have a better result than I have been for the better of this part of the semester here. I haven't been doing too well in these labs, but hopefully we get this one going pretty well. So anyway, what is a ferrofluid? Ferrofluid is a fluid, contains nanoparticles or small particles of a magnetic material. And in this case, if you didn't know, toner actually is a magnetic fluid or ferrofluid because it does contain small particles of magnetic substances within its design. So how this is going to work, we already have our toner in our cup here. I roughly estimated that it's about 50 milliliters, and we're going to add our 2 tablespoons of vegetable oil, and then we have our rare earth magnets here. I got the rectangular ones. It's got 8 smaller magnets, so if we need a little bit of extra power to pull this off, I went ahead and made sure I had a little extra magnetic power to do so. And I went with a blue liquid toner. This particular one is a Epson brand. So let's see what happens. So let's go ahead and get our vegetable oil introduced into our ink toner. So I think probably have probably less than 50 milliliters of toner in there. So we're going to start with 1 tablespoon of vegetable oil. So I think that was probably like a 2-to-1 ratio of toner to vegetable oil. And let's see what happens. So if we need to add more, we can do so. So we're going to take our stir and mix it up. Check the viscosity and make sure it's thin. Checking it in the light here. All right, I think we're good to go. Looks pretty thin. Don't want to spill this anywhere of any importance. All right, so we're going to start, like I said, I have 8 pieces of magnetic material here. We're going to start with, we'll start with 2, and we'll kind of go in bricks of 2 from there. See what happens. So let's cant this on our side here. All right, so with 2 bricks, we're not getting any reaction whatsoever. So let's try it with 4. Okay, nothing there. Let's just go with all 8 and see what happens. If this doesn't work, we'll pause, I'll reset, and we'll come back later. Which is exactly what we're going to do. So we will be right back once we get this to work. Okay, so we're back, and unfortunately I don't have some good news to report. So for whatever reason, I'm not off or I haven't been on a good streak here in this part of the semester. For Chem 126, these experiments, most of them haven't worked, and this one's no exception, unfortunately. So I thought by going and getting the more brick style rare earth magnets, it would give me more magnetic power. So I was pretty hopeful. But after doing some more research online on this experiment, watching a few other videos, what I thought was liquid toner in our video ended up really I needed to use powder toner instead of the liquid toner that I ended up using. So that to me is the reason, or at least my my reasoning as to why this isn't working. I've tried using the magnet in in a plastic cup to see if it would magnetize, but it's not. I've even let it separate a little bit from the oil before doing it, mixed it back up, added a bunch more toner, took a bunch out into the glass container, still not having any success. So that leads me to believe that the toner that I purchased is in fact not a ferrofluid in and of itself. So I did try to read on the Epson website about the specific ink that I purchased. Couldn't find anything concrete to say whether or not it was made with magnetic materials or not. But again, going back to all the other videos, probably watched 4 or 5 other ones about this experiment, and they all used powder toner. So to me, like I said, that's likely the reason as to why this particular one didn't work for me. But in any case, what we should have seen is the creation of the ferrofluid. Again, the toner should have, in our case, tiny magnetic particles within the toner powder itself, and in combination with the vegetable oil, we would have created a ferrofluid. Again, ferrofluid is just a fluid that has tiny magnetic particles floating around within it. And in a couple of the videos that I watched, the way they kind of explained what we should have seen would be analogous to what you see when milk curdles. You have the fat portion that clumps together, and the whey that doesn't. And the reason that's kind of analogous is the same kind of reaction is happening here with our ferrofluid, right? So the reason they don't fall apart and they show up as spikes, or they should have shown up as spikes, is because of it's a colloid. So the kind of like hand soap as well, right? So it clumps together to create the spikes, or you should have created the spikes to kind of keep it together and show us the artistic capabilities of ferrofluid. But unfortunately, that wasn't to be seen in my experiment. So should have seen it that way. That's the reaction that we should have seen. The magnets obviously reacting with the magnetic particles in the ferrofluid to give us the spikes and other whatever other substance or version of that reaction that we would have seen in our container. So unfortunately, another unsuccessful experiment for me. Hopefully we can wrap up the semester next week with a successful experiment, and we'll go from there. So thank you very much, and we'll talk soon.